Hey everyone.
Hello.
I think Eddie said that he had a conflict at the beginning of the call with a personal thing, so he might be joining a little late. I think that's what he indicated, or maybe routing W group start. So I don't know if he might join a little later or not. So once we have the quorum and the presenters, I think we can probably get started. I believe there was one agenda which is Hun and Yuking, if I'm pronouncing the name incorrectly, apologies. Jun was going to present the BGP path memory usage reduction, the work that he has done. And then Yuking was going to present the BGP node memory usage reduction. So, Yun and Yuking, are you guys on the call?
Yeah. I'll share my screen. Thank you.
Okay. Maybe we give another minute or so, and then you guys can take the ball and start rolling.
Yeah.
Okay. Let's just give maybe another, it's 3 minutes past, maybe just one more minute, and then. You can probably start sharing in the meanwhile.
Okay. Can you see it?
Yeah, we can see it. Yeah.
Okay.
Is there any way you can go to the slideshow mode? That might be easier to visualize.
Okay.
Okay, cool. Yeah. I think we can probably start then.
Okay. Hello everyone. My name is Jun He. I'm from Tsinghua University and worked as an intern in Alibaba. My work part is about structured memory optimization of FRBGP. This work is mainly directed by Donald and my internship mentor Han Yu in Alibaba. The BGP pass info extra data structure in FRBGP is used to record some ancillary information about one BGP route. But the former problem is that not all attributes inside are used at any time. It causes a waste of time. So we can consider the following three things to make optimization. First, we can create new data structures by attribute classification. Then we can choose to allocate memory space only when we need. Then and we can also remove redundant attributes to further reduce the memory consumption. Specifically, we create three new structure for EVPN, full spec, and VRF leaking scenarios respectively to store their related attributes. Then we create three corresponding pointer variables for the three new structures. After modification, the structure of BGP pass info extra is changed from the left figure to the right. And as you can see, we delete the seed and the number seeds in the new BGP info extra. And the next I will introduce the timing of memory allocation and the reasons for removing attributes. And after we create three corresponding pointer variable, we need to choose the proper time to allocate memory space for them. For EVPN related attributes, they are only used when the prefix address family field of this route is AF EVPN. We check this each time we create a new BGP pass info extra structure variable. If it is, we allocate. For spec related attributes, these attributes are used when flowspec is enabled on some routes. So we allocate memory space for flowspec attributes only for those specific routes. As for VRF leaking related attributes, when VRF leaking occurs, A new root and its BGP path info extra variable will be created. The new BGP path info extra variable will use this verb leaking attributes, so we allocate for it. As mentioned earlier, we delete seed and the num seeds because seed information here are copied from ATTR field of path info. But after copying, no changes were made to these two attributes, so we can just delete them. And then I choose a few typical test cases to get an initial look at the optimization effect. Some test cases such as BGP, ECMP top one do not use BGP parsing for extra data structure, in which case there is no optimization effect. Some test cases such as BGP aggregate address top one use the extra data structure and do not use our dynamical allocated attributes, since the size of an extra structure variable is reduced from 432 bytes to 176 bytes. It reduced the memory usage by about 60%. In some of the other test cases, the attributes we moved are used. So new structure variable will be created, and it will reduce the memory usage by about half. What's more, we test the stability of large-scale root announcements and the withdrawal in EVPN scenarios. BGP's memory changes are as expected when we install or remove roots with sharp daemon. It looks stable after modification. And from the right two figures, we can see that when a router receives about 500,000 EVPN routes and link them to its local verb, BGP extra info memory was reduced by 46% after our optimization, which is about 200 million bytes. From the previous simple test, we know that we can even save more memory space in some other test cases. In the end, the modified code has been merged into the master branch of FR. I'm glad to take part in such open source community work. Thanks for the help of all my mentors and colleagues. Thank you. That's all.
This was pretty good. Thank you so much.
Yeah, Sam, on my side, the changes make sense. Modularization of BGP memory allocation is a good thing to do. And good that you tried to test at scale. And we see now degradation. To my understanding, we see now degradation in processing time or convergence, right?
Yeah.
Yep, thank you. Good stuff.
Thank you.
Maybe I can ask.
Yes,
I can ask one here on the same topic, actually. So do you see any other avenue where we can further reduce the memory consumption?
I found that there are also some redundant attributes in some data structure, like the RMB in and the RIB out. But I have not figured out how to deal with that attributes in the data structure. I think there are also some redundant, but in my personal respect.
You're saying rib in and rib out?
I see that in I found some attributes are also kind of copying in the RMB in and the RIB out
Right.
data structure.
Correct.
But
they're separate.
I have not seen that in detail.
Yep, I think that's a good point.
Thank you.
Thank you.
All right, so if there are no questions, can we move to the second topic?
Thank you.
Thanks, Son. Yuking, are you going to share?
Yes.
Okay.
Thank you. I'll share my screen. Can you see that?
Yes, can see.
Okay. Hello, everyone. This is Yuqing. Today, I'll talk about the project of Alibaba Summer of Code, reduce BGP node memory usage, and this is based on Donald's idea at work. I'll introduce the work from 5 aspects. Firstly, the current situation of BGP node, and then the improving method, BGP node breakup. And next is about the impact of the change, the optimization results, and finally show the links of more details. So the current BGP node codebase is the struct BGP node data structure. It mainly contains 2 parts of members, as is shown in figure 1. One is the root information named root node fields, is a macro definition, and the other is about BGP data. Well, the situation about that is the table structure generates some holder nodes that are never going to receive BGP routes. The figure 2 shows an example of what holder node is. As we know, the structure of nodes is a binary tree. If we have 2 BGP nodes, 1.2.3.0/32 and 1.2.3.1/32, there will be a holder node, 1.2.3.0/31, pointing to them. These holder nodes are never going to receive BGP routes, but now the memory of this kind of nodes is allocated as if they are a full BGP node. The problem with this is that it creates a bunch of extra data per node. This is a significant amount of memory that we do not need to allocate the BGP node for. And for these holder nodes, root node will be preferable. So the improving method is to break up the struct BGP node. Split up the BGP node into struct root node and struct BGP dest. The root node is an original data structure, and the BGP dest is extra. In the existing FLR code, the BGP dest is a macro definition, and it has the same structure with BGP node, but what we are talking about here is a new one. The details of the breakup is shown in figure 3. In root node, there's a pointer named info pointing to BGP dest, and in dest, there's a pointer rn pointing back, so they can find each other via pointers. And the relation between them is set when creating the BGP dest. At the same time, this change has some impacts that needs a little attention. The first one is BGP dest doesn't have the root node fields as its member anymore. So if you want to access them, you need to use the pointer rn. Then the dest needs to be freed after use based on the lock logic, which is in the BGP dest and lock node function. The third one is, after the change, the BGP dest sometimes doesn't exist. So a null check on it is necessary in some places. The figure 5 shows the impact of variable usage. This is how to visit p-point family where pointer rn, and this is a null check example. The figure 6 shows the free operation of test when the lock is 1. Another thing we need to pay attention to is we need to make sure the BGP test is freed before setting the RN pointer info now, because this pointer keeps the relation between test and root node. If we set it now too early, the BGP test may get lost and the memory leak will occur. The figure 7 shows an example when I was facing the memory leak issue. It was so obvious the leak is from the BGP test because the size of it is exactly 96 bytes. And the figure 8 shows the logic of getting the test from the root node. Now we are going to allocate the root node instead of the BGP node for the holder, so the memory usage is reduced. The memory usage of struct BGP node is 200 bytes, while struct BGP test is 96 bytes. As for the total memory usage optimization of this part, the root node should be taken into consideration as well. So I tested the effect of different numbers of roots from 200 to 1 million. And the optimization rate remains at around 16%. And my code is still under review now. If you are interested in this project, here is my PR link. Thank you. That's all.
Thank you, Jen. Is this PR, is this merged or is it open right now?
Oh, it's open. It
Okay,
haven't been
okay.
merged. Okay, thank you.
Thank you for following Donald's advice on locking, and good work too. And let's make sure Donald reviews it again before you merge.
Oh, sorry, I didn't get. Could you repeat that?
Let's make sure Donald reviews it again. So I see that
Okay.
you addressed the locking issue, but before you merge, let's make sure he reviews it.
Okay, thank you.
Thank you. Good stuff.
But I think those were the two topics we had on the agenda. Does anyone have anything else today to discuss? Okay. In that case, I guess we would adjourn early.
Bye, everyone.
Yeah, thanks everyone.
Thank you.
Thank you.